So deltas are a really important indicator that there was once a lake in Jezero Crater, and we see them elsewhere on Mars too. But they tell us that a river once flowed into this crater, filled it up to form a lake, and then kept flowing to eventually form this delta out into the lake. And that's really exciting just for telling us that was in fact a sustained, ancient, habitable environment where ancient microbial life could have lived. But it's also really great for preserving biosignatures, preserving things like organic molecules from that ancient life. Because deltas, what they do when they build out into lake, they actually build out and cover up the really muddy, organic, rich material that builds up on the bottom of lakes. And so on Mars, this delta we're looking at, it's actually been eroded back a couple of kilometers. And so at the bottom of the delta, we think those ancient, muddy lake bottom deposits are exposed and just waiting for us to go look at them. On Earth and lakes, those are exactly the kinds of deposits where we see lots and lots of buildup of organic material from life, in the watershed, from the rivers, and also from the lake itself. So it's sort of this giant, waving red flag telling us to come look at it for organic materials and to look for signs of ancient life. As we're exploring Jezero Crater, we're collecting little kind of pen or pencil-sized samples, little cores of the rocks there, and that's so that we can bring them back to Earth to verify whether or not there are signs of ancient life in those rocks. We love to do that with the rover itself, and claim signs of life with the rover, but we know that to really do that well and for sure, we need to bring those rocks back to Earth. So we're basically, as we drive along, we identify a rock that we think is really interesting and we think will be really great for study back on Earth. We stop, we take a close look at it, and then we drill into it with the rover and keep that sample core in a tube that we carry on board the rover. At some point soon, we are hopefully going to lay down a set of these tubes to cache them on the surface for eventual return to Earth. And that'll actually happen through a series of other missions. We call this Mars sample return. And that'll happen through, another small rover coming out to grab the samples, putting them on a little rocket, which will launch into orbit, rendezvous with another satellite, and then eventually return that back to Earth. So basically, Mars 2020 and this rover is just the first step in a much longer process to get those samples of Mars back to Earth. When we talk about looking for life on other planets in our solar system, we're really talking about looking for microbial life, really very, very small, very primitive creatures. And that's because we don't think that other planetary bodies have really had the same kind of time for life to evolve they have on Earth. In Jezero Crater on Mars, where we're collecting these samples of Perseverance, we think it was a habitable kind of wet, lake environment, something like between 4 and 3.5 or 3 billion years ago. And so you can think about what life looked like on Earth 3 or 4 billion years ago, and it was all microbes, right? Up until a few 100 million years ago, life on Earth was just all microbes. So unless we think somewhere else in the solar system has had the same kind of time to evolve into animals and more complex life, that's when we talk about looking for life in our solar system, we're talking about looking for microbes. The one thing we're hoping to find with this rover is that we're hoping to find, concentrated organic molecules or textures that could be due to microbes. There are things that we can see with the rover that may help us identify potential biosignatures. We just, we're always going to be careful and say it's potential until we bring it back to Earth and look at it carefully. So I imagine that, maybe even this year sometime, we might be able to say something about the potential for life in these rocks. And then after we get the samples back, it'll probably be, another year or something, even a few months, depending on how obvious the signs of life are before we can really report that out.